So this is a video going over some of the parallel line and auxiliary line proofs that we didn't get a chance to talk too much about today in class. If you lost this packet, it's the one that has the auxiliary line problems at the top. But if you don't have it with you, you could just look in the description and print out a Word document of it there. So for number 5, they tell us that J is parallel to K, and that M is parallel to N. So now I've got two sets of parallel lines, and they want me to prove that angle 5 is congruent to angle 6. So the first thing I notice is that they give me this angle 7 right here. So maybe I can use that to somehow link 5 to 6. So the first thing I look at is for angle 5 and angle 7, I can say that those are congruent because they're corresponding angles. If we look at M and N and use J as a transversal, then they're on the same side of the transversal, but one's outside the parallel lines and one's inside the parallel lines. So those are corresponding angles. So I know when I write out my proof, I can say something about corresponding angles as my reason. And then 7 and 6, so 7 is going to be equal to 6 because if I'm looking at now J and K as my parallel lines, and I'm looking at N now as my transversal, I notice that those are alternate exterior angles. They're both on opposite sides of the transversal, and they're both outside the parallel lines. So they're not being squished between them. Okay, so let's take a look at what I said for the proof. The first thing you do is list your givens. They told me that J is parallel to K and M is parallel to N. I'm going to use both those facts somewhere in my proof because corresponding angles and alternate exterior angles only work if the lines are parallel. So I said that 5 is congruent to 7 because parallel lines cut by a transversal form congruent corresponding angles. You need all of that in your reason because if you don't know that they're parallel lines, like if I have a picture like this, these two angles are still corresponding, but they're not congruent. So we need to mention that those are parallel lines. 6 is equal to 7 because parallel lines cut by a transversal form congruent alternate exterior angles. Notice how similar that is to my other reasoning. We all have the whole parallel lines cut by a transversal, but the only thing different is that I call them alternate exterior angles instead. My next statement was that 5 is equal to 6 just by substitution. So if 5 is equal to 7 and 6 is equal to 7, then I could just say that these two are equal to each other by substituting in this 6 for that 7 right there, or vice versa. Number 6. Given P is parallel to Q, the measure of angle 8 equals 60, prove that the measure of angle 9 equals 120. So I'm going to do the same thing I did in the last problem, where before I even thought about the proof, I analyzed the picture. So they tell me that 8 is 60, and I notice that 8 and 10 are on the same side of that transversal there, and they're both inside the parallel lines. So I know 8 and 10 are same side supplementary. So if they're same side supplementary, if I take 180 and subtract 60, I know that the measure of angle 10 should be 120 degrees. And I'm trying to prove that 9 is 120 degrees. I notice that the measure of angle 10 is going to be equal to the measure of 9 because they're formed by intersecting lines and they're opposite each other. So those are vertical angles. So I think that's enough for me to say that angle 9 is 120. So I stated my givens. I said that the measure of angle 8 plus the measure of angle 10 equals 180 because parallel lines cut by a transversal form same side supplementary angles. Then I substituted in 60 degrees for 8, and subtracted 60 on both sides to find that the measure of angle 10 is 120 degrees. Then I stated that the measure of angle 10 is congruent or equal to the measure of angle 9 because vertical angles are congruent. And I finished just by substituting in 120 for the measure of angle 10 to say that the measure of angle 9 equals 120. Notice that whatever you're trying to prove is always going to be the last statement in your proof. Number 7. Given S is parallel to T, the measure of angle 11 equals 80, and the measure of angle 12 equals 160, prove that the measure of angle 13 equals 100. Well, anytime we've had parallel lines cut by a transversal, it's always just one transversal that they're cut by. But if I notice in this picture, we've got a transversal right here, but it doesn't continue to cut through the other line. It kind of kinks and goes off in a different direction. So when I'm seeing this sort of picture, I don't have any alternate interior angles I could work off of, no corresponding angles. So anytime I see that kink in the transversal, I'm thinking to myself, I might need to draw some sort of auxiliary line here, or an extra line that might give me alternate interior angles. So I'm going to draw in a line right there, and I draw it so that it's parallel to my given lines. Otherwise, it wouldn't really help me out that much. Remember that alternate interior angles are only congruent if the lines are parallel. So let's see what we can get going here. Notice that I split angle 13 into two angles. This purple angle right here, and this blue angle right here. So I'm going to label the top angle as A, and the bottom angle as B, just so I have something to refer to as I'm writing my proof. So I know that 11 is 80, and the measure of angle 11 is equal to the measure of angle A, because those are corresponding angles. Remember, corresponding angles fall on the same side of the transversal, so if that red part is my transversal, they're on the same side, but one's on the inside of the parallel lines, that's A, and one's on the outside, that 11. Alright, so that's one part of 13. I need to be able to say something about B, though. Well, if 12 is 160, I know that the measure of angle 12 plus the measure of angle B is equal to 180, because those are same side supplementary. Remember, those are angles that are on the same side of the transversal. So if the transversal is that blue piece right there, they're on the same side, and they're both interior for those parallel lines. Notice that one of them's acute, and one of them's obtuse, so I know they can't be congruent to each other. Okay, so if measure of angle 12 is 160, we could say that the measure of angle B is equal to 20 degrees, just by subtracting 160 from 180. And from there, I know that 13 is made up of angle A plus angle B. So in my head I'm thinking, okay, if B is 20 and A is the same as 11, which is 80, if I add those up I get 100, which is exactly what I'm trying to prove. So now that I've done my analysis of the picture, I go to the statement, reason, proof. I first state my givens, so everything they told me to be true, which I was going to use in my proof. And the second thing I say is to draw an auxiliary line parallel to S and T going through the vertex at angle 13. I need to say that it's parallel because that's what is useful to me, and I need to say that it goes through angle 13. And the reason for that is just that you can draw an auxiliary line through any point. If you just want to say auxiliary line, I'm fine with that for now. The third thing I said was that the measure of angle 11 equals the measure of angle A because, again, parallel lines cut by a transversal form congruent corresponding angles. I substituted in that 80 for the measure of angle A, and the next thing I said was about those same side supplementary angles. Notice the similarity between all of these statements. I then say that instead of the measure of angle 12, I just write what the measure of angle 12 actually is by substituting in that value. Then by subtracting 160 on both sides, I find that measure of angle B equals 20. And I know the sum of the parts is equal to the whole. When we drew that auxiliary line here, we broke 13 up into two different parts. So I need to state that 13 is made up of those two different parts. And it doesn't matter what you call it. You could call it angle X, angle Y, angle 1, and angle 2, as long as those labels haven't been used yet. And then I say that by substitution, so substituting in 80 for A and 20 for B, we can say that the measure of angle 13 is equal to 100.